Welcome to this webinar on connecting 2D and 3D. I'm Clint Brown, and over the next few minutes, I'm going to run you through everything you need to know about how to connect your workflows between AutoCAD and Inventor, and vice versa. So we say that the ends are more important than the means, and in reality, it doesn't matter how you get to the final design, whether you start in 2D, do something in 3D, do it all in one or the other. At the end of the day, we know that you need to get your work out. Your work is judged by its output. So to you, the means are crucial. You need the right design platform that powers your success. And whether that's 2D or 3D doesn't really matter. So when we talk to people about moving from 2D to 3D, often they have a bunch of different objections. Designing 3D, they said. It'll be fun, they said. It actually is fun, and the downstream benefits of 3D far outweigh the choice of moving to it. But some of the concerns we get are a new system removes expert level familiarity, seems like overkill, are we using a sledgehammer to swat a fly, and what about legacy data? So we're going to answer all of these questions as we go through this today. Moving to 3D is actually really easy, and as I said at the top of this, the downstream benefits of 3D are huge. But what if we didn't have to choose between 2D and 3D? What if the best solution was a collection of interconnected products that allow us to easily switch between 2D and 3D? Well, that's what we're going to look at. We're going to choose the right tool for the job, and off we're going to go from there. So we're going to look at building a seamless association between 2D and 3D platforms. The best part about this is that we keep your data intact. We integrate you at your own pace, so you're not forced to move all the way over in one go. You can choose the design tool that works best. So you might have some jobs that are still in 2D that you want to finish, or old jobs that are just easier to finish in 2D. And then we're going to look at using 3D visualization when needed, and we can even do that from your 2D data. So connected workflows. And that's thanks to associativity between AutoCAD and Inventor. So if you're transitioning from AutoCAD to Inventor, or if you're collaborating in a mixed 2D and 3D workflow, you'll want to know how to reuse 2D AutoCAD geometry to create 3D models in Autodesk Inventor. To get started, you import your DWG file into Inventor as an associative underlay. You choose the geometry that you want to use from AutoCAD by controlling layers and cropping out what you don't need. Now that you have the 2D geometry in Inventor, you can build the 3D model. First, create a new sketch, then project the 2D AutoCAD geometry. This makes associative links back to the original DWG, so whenever a change is made to the AutoCAD source file, it'll update inside of Inventor. Use extrude tools to create solids from sketches you've just created. Build the parameters into the model that reference the DWG by dimensioning the AutoCAD layout, which creates new parametric relationships. In just a few minutes, you've completed the 3D model and created your 2D drawing. After you add the part to an assembly, you place constraints, and you might catch errors in the design. In this case, the error is with the dimensions. This is an easy fix thanks to the associativity between AutoCAD and Inventor. Edit the drawing in AutoCAD and see the model update in your assembly. Repurposing your existing 2D data to create 3D models is just one of the ways in which AutoCAD and Inventor work better together. Okay, so legacy data lives on. We can reuse all of your existing 2D data by referencing the DWG files in Inventor as associative underlays, as you saw in that little demonstration before. The best part about this is that there's no need to do any cumbersome migrations. Your 2D data as it is perfect to be reused. So design on one platform, visualize in another. You can enjoy the flexibility of AutoCAD for fast mechanical concept design, then import that 2D concept into Inventor. We create 3D models, and we can then check interferences and analyze motion. The ability to do concurrent design. So if you do electrical design, one of the tools that comes with our collection is the ability to use AutoCAD Electrical, and we can then create associativity between 2D electrical layouts and 3D Inventor models. So we can reduce time spent on manual tasks by adding parametric modeling to your development process. We can handle late-stage design changes more easily and automatically update all downstream deliverables. And I'm going to show you how this looks in a second. So So one of the things to bear in mind is that a change made anywhere updates everywhere. And this is really important. So if we make a change to our 2D documentation and we've linked that into our 3D models update automatically, and that'll update things like the mass and the bill of materials. And think about the current state if you're only using 2D data. If you make a change in 2D, you have to manually redraw those changes everywhere. So this could be downstream documentation, it could be in other views, and if you forget one, you could potentially make a mistake that could be quite costly. So in this example, we have an AutoCAD drawing, and if we make a change to this rib over here, we move it up slightly, we save our drawing back. Because it's referenced in Inventor, our 3D model updates automatically, and you can see the change to that rib in 3D. So an update anywhere updates everywhere. Parametric 3D modeling not only helps you get the job done faster, but it also provides the basis for additional work to improve the performance of your products and make the process of getting into manufacturing easier. Quickly make parametric design changes in Inventor and you'll see the updates reflected in the 3D model. Connectivity with downstream deliverables such as drawings, renderings, FEA simulations, NC toolpaths, and bill of materials mean that whenever your 3D model changes, it'll be reflected everywhere. You can automate common modeling tasks and control product configurations. Built-in rules-based design can help you drive objects and parameters. No complex programming necessary. We call this iLogic. Use your 3D models to optimize performance and streamline your development process. With Inventor Nastran, analyze your models in the CAD environment, including nonlinear, fatigue, and thermal simulation. Idealizations such as bolts, beams, and rigid elements help produce quick and accurate results, and choose from a variety of nonlinear material models to handle advanced scenarios, including foam, composites, and rubber. Inventor's tolerance analysis reports the mechanical fit and performance of designs based on dimensional tolerances. Within Canvas workflow that uses GD&T right on your model, analyze critical areas of your design to ensure that they satisfy your objectives for manufacturing. In the tolerance analysis panel inside of Inventor, you'll immediately find worst case and root sum squared results for dimensions that contribute to the stack up, as well as bonus statistical results for CPK, sigma, defects per million, or yield. Then quickly create a full report, including imagery, of tolerance objectives and results. And finally, generate toolpaths with CAD integrated multi-axis CAM. Even if you make a change to your design, the CAM toolpaths will update automatically. With Autodesk 3D CAD, streamline design work and benefit from downstream applications of 3D models, from advanced simulation to manufacturing preparation. Okay, so forge tighter connections between design and the shop floor. We saw there that if we update a 3D model, we instantly update all of our downstream deliverables. So think about things like our NC toolpaths. We change the 3D model, our toolpaths update automatically. Huge time saving, I'm sure you'll all agree. All right, get a level up in automation. So spend less time on drudgery and more time on innovation. We can automate common modeling tasks and control product configurations with built-in rules-based design technology. We can easily define our logic with no complex programming necessary. So you saw the example of these balconies. Using some of the iLogic technology, we can go in and apply some of our design rules to the model, and through a form interface, we can control our model, giving us faster design iterations. Right, get more value from your 3D. So remove lost in translation issues by communicating in a more intuitive language. You have the ability to perform advanced simulations, produce high quality visualizations, create NC toolpaths, and generate documentation that automatically reflects changes to the original design. What about moving Inventor models inside of AutoCAD? So creating or editing drawings and documentation inside of AutoCAD based on your Inventor 3D CAD allows you to participate in common activities with your colleagues, partners, or clients. The first option to do this is to create a drawing directly inside Inventor as a native DWG file. Now you can open the file you created in Inventor directly inside of AutoCAD Mechanical, no translation necessary. Inside of AutoCAD, you can add 2D details or insert annotations, revision clouds, and dimensions. You round trip the file by opening the same DWG back inside of Inventor, and you'll notice that your 2D information stays associative between both CAD environments. You need to make changes to your Inventor model, your AutoCAD drawings will stay up to date with the latest revisions. Even changes to dimensions added in AutoCAD will remain associative. If you prefer, you can also create 2D drawings of your 3D Inventor models directly inside of AutoCAD Mechanical. Create your model in Inventor, then use your familiar AutoCAD tools to detail your drawings. Creating native DWG drawings that are associative to your 3D CAD models is another example of how AutoCAD and Inventor work better together. We can also optimize design performance and easily reuse models. So we have the ability to do full-on Nastran simulations on top of our designs. And as you've seen already, it's really simple to bring your 2D to life in 3D and to then run simulations on top of it. So here's a great example. We've got a component over here, and we're applying a few constraints to it. And once we've applied our constraints, we can go ahead and add a load. In this instance, we're going to apply a moment to the pin that runs through the middle of this component and automatically generate our mesh. Once we've done that, we can run our simulation. We'll be able to see how our model behaves under that moment load. And there we go, and we can see all of the stresses and displacement on the model. Right, another fantastic option we have inside of Inventor is the ability to do nesting. So here's an example where we're running a nest based on a 2D DXF. We load that DXF into Inventor, and we can nest our components, and we can see what our nesting efficiency looks like. From here, we can export out to a 2D DXF or an AutoCAD file, which we can send to a CNC machine or a laser cutter. But from Inventor as well, we can turn our 2D into a 3D model. Remember, we started with a flat DXF file, and we can now turn this into a 3D model. And from that 3D model, based on the thickness of our nest, we can now do things like create CNC profiles for water jet cutters, laser jet cutters, or traditional 2D milling. So the world is flat and it's also round. Inventor offers us the ability to do a bunch of things inside of 3D. AutoCAD gives us the ability to do 2D design and layout, but you can see that they work really well together. What you see isn't always what you get. Parametric 3D CAD can mean the difference between confusion and clarity, giving you intuitive models that make sense to designers and non-designers alike. Plus, there's more to 3D CAD than better design visualization. Your entire development cycle has something to gain. Adding 3D means that you can spend less time on manual tasks and design challenges, boosting design efficiency. Connected 2D and 3D workflows ensure that you always have the right tool for the right job at hand. Plus, the ability to perform advanced simulations, produce high-quality renderings and animations, create NC toolpaths from models, and generate documentation that automatically reflects design changes. You can get so much more out of your 3D models. These tools help designers work more efficiently, bringing collaborators more in sync and empower you to deliver more value to your customers, from the first draft to the final deliverable. 3D Inventor plus 2D AutoCAD is better together. Thank you for your attention. Please get in touch with your account manager if you need any more help with any of this or if you have any questions. And really, I hope that you enjoyed this webinar.